Welcome to part 2 of our second unit. Now, for the second half of this unit, we're going to be taking a look at regression, linear regression, and other types of regression as well. All right, in our previous activity, we looked at just one variable data related to student heights. We were comparing the heights of my first period students to the heights of my third period students. In this section, we're going to explore the relationship between two different quantitative variables. So we're going to look at them on the same exact graph and see how they're related to each other. Now, below are scatter plots. All right, which are a type of graph that compares two quantitative variables. One variable is the explanatory variable and the other is the response variable. Now the explanatory variable, think explanatory, goes on the x-axis. Right, it's your independent variable. Now the other, the response variable, goes on the y-axis, and it's usually what we're trying to ask why about. We're trying to figure out why something happens. Now the key descriptors in a scatter plot are strength, direction, shape, and unusual patterns or outliers. Let's skip down here to this next section. And strength relates to the correlation coefficient, which is R. All right, we'll get to what the correlation coefficient is here in just a little bit. But I want you to imagine an oval around your data. All right, so this oval is nice and narrow and skinny. And this one takes up a bit more space. Now the directions of each of these are still very obvious. But notice that one of these graphs is described as strong while the other is described as moderate. That's because of the scatter within the points as you follow the relationship of the graph. All right, these points follow the same direction fairly closely, while these points scatter a little bit more about the line that we might draw through the center, the average of these values. All right, now there's a numerical value for strength, which is why we call this a coefficient. All right, so the value of R is between -1 and +1. All right, it can be weak, which means that the absolute value of our R is going to be between 0 and about 0.4. I'm saying absolute value because this could be between 0 and -0.4 also. I'm omitting the 0 because 0 means exactly no relationship. Like if you try to draw an oval, you're pretty much just going to get a circle. Right? There is no like positive or negative direction to this. You would just essentially have a flat line through this. All right, moderate would be from about 0.4 to about 0.7. Now 0.7 is right when we start to shift over to a stronger relationship, which is why I didn't put the or equal to line underneath this. And again, I'm showing the absolute value of R because this could be between -0.4 and -0.7 as well. I'm using the absolute value to show that this could either be on the positive side of the R values or the negative side of the R values. And then strong is between 0.7 and about 0.9. And once you get up to 0.9 and higher, right, this tops out at +1. Then you're getting into the very, very strong category. Now, when you're right between moderate and strong, like 7, 7.5, or 0.7, 0.75, 0.65, you could actually call those moderately strong. So you can actually combine a couple of these. You can call something moderately weak. So when you're sort of on the cusp of going to the very next description, you can actually combine the descriptions if you're not sure which one to use. All right, so later we're going to learn about the correlation coefficient a little bit more and the coefficient of determination, which is R or R squared. All right, direction can be either positive or negative, or it could be null, as in there is no direction to this, kind of like the circular one. All right, now this one is going in a positive direction. If I were to draw a line through this, then as my x's increase, so would my y's. All right, this would have a positive slope. If I draw a line through this one, my y's would be decreasing as my x's increase, which would give me a negative slope. So think about the sign on the slope value that you would have for these, right? Which is what I have written here. For linear patterns, think of the slope of the best fit line or the least square regression line to figure out what direction that slope would actually be going in. And the shape primarily deals with whether it's linear or not. And if it's not, then it could potentially be a curve, such as an exponential function or quadratic, or it could have absolutely no pattern at all. So these top two are linear. One is positive linear, and then the other is negative linear. Down below this, you have one that has a null relationship. Basically, you would have a flat line, meaning that the y doesn't change with x. So you can't actually make predictions for y based on x because we can't tell what direction this is even going in. And this one right next to it, I didn't draw an oval or anything around this one because it's a strong shape, it's a nonlinear shape, and if you draw the shape that would go through the central trend of these points as x increases, so you can see the central trend of the y values as x increases, what you're really seeing is something that looks quadratic. And it looks like a negative quadratic function. And finally, we would want to deal with any unusual patterns or outliers. This step is a reminder to just look for unique looking behavior in the graph or individual points that may affect the graph. So you could have a single point that affects the graph rather dramatically and changes the strength of the relationship or the direction of the relationship. Or you may have like clusters of points that are actually creating the linear or curved relationship that you're seeing. So it's always good to take a look at what kinds of unusual patterns might there be, and are there any outliers? Now, unlike our last unit, there is no formula for actually determining for sure whether or not we have outliers. You kind of have to eyeball it and see what effect that value has on the relationship that we're viewing and how we look at that relationship. All right, now let's go to the next page. And here's where you have some practice. Now, I want you guys to actually break into groups and practice this, but let me model one of these first. So for this practice section, for the following scatter plots, identify the explanatory variable and the response variable, the strength and direction, so you're going to do this all in words, and if the graph is not linear, state the shape and or unusual patterns in the parentheses, otherwise just circle linear. So for this first one, we have Old Faithful Eruptions. Now it's going to be a little bit difficult to actually read this, but the x-axis says eruption duration in minutes, and that's your explanatory variable. So eruption duration minutes. Your response variable is what's on the y-axis, and this says waiting time between eruptions in minutes. So I'm going to abbreviate that as time between eruptions in minutes. Now, strength. If we draw an oval around this, that oval is fairly tight. Even though there's some decent scatter around this line, there aren't any points that are really pulling super far off from this. You can tell the direction of this fairly consistently. And that's usually the hallmark of a strong or a moderately strong relationship. So I'm going to call this one strong. You could call it moderately strong if you're not quite sure. The direction, as x is increasing, so is y, and that would give me a positive slope, so this is a positive direction. And it appears to be fairly linear, but I do have something unusual. I have two distinct clusters of points. Right, so two distinct clusters of points. that are creating this linear relationship. Now I do have a couple of points in between kind of linking them, but the majority of points are either in the low x values with the low y values or the high x values with the high y values. There are very few parts in between, which is interesting. So that's something that you'd want to note, and that's why I put this in the parentheses. All right, now I want you guys to go through and try the rest of this in your small groups, and we will regroup and discuss these later.